Hi friends, welcome to Civil Engineering and Programming channel. In this video I will explain you the derivation of displacement function and shape function for one dimensional bar element, one dimensional line or bar element. Okay, let us consider a bar element. Consider a bar element. Okay, bar element having two nodes, two having the two nodes 1 and 2 as shown in below figure. Okay, as shown in below figure. Okay, you can see it. Let us take this is a bar element. Okay, this is a bar, or we can call it as a line element having the two nodes 1 and 2 having the length. Okay, length of this bar element is L, small l, and here let u1 and u2 are the displacements at node 1 and 2 respectively. Okay, then we know that polynomial function for one dimensional bar element is polynomial displacement function u is equal to a naught plus a1x, this is equation number 1. Okay, equation number 1, where a naught and a1 are general coordinates. Okay, general coordinates, or we can call it as a global coordinates. Okay, global coordinates. Then you have to write the equation 1 in matrix form, in matrix form. Okay, let us write how we have to write this in matrix form is u is equal to a naught a1. Okay, a naught a1 into, okay, 1 into x, 1x, that is equation number 2. Okay, equation number 2. Then next step is apply the boundary conditions for bar element, Okay, let us say this is the bar having two nodes. Okay, u1 and u2, and this is having length L. Okay, then at node 1 x is equal to 0, that is here x is equal to 0, then u is equal to u1. Okay, at node 2 x is equal to L and u is equal to u2. Okay, substitute the above values in equation number 1. Okay, means we have to substitute this in this equation number. Okay, equation number 1. Then what will happen? Then you'll get u1 is equal to a naught, u2 is equal to a naught plus a1 L. Okay, this is equation number 3 and this is equation number 4. Okay, then write equation number 3 and equation number 4 in matrix form. Okay, in matrix form. How we have to write in matrix form means u1 u2 is equal to, okay, how we have to write a naught a1. Okay, a naught a1, this we have to write 1, a naught coefficient, that is y, a naught. Okay, and 0, then 1 L, 0 1 L. Okay, this is the matrix form of the equation 3 and 4. Okay, how you have to write? You can see u1 u2 is equal to, first you have to write a naught a1. Okay, What is a naught coefficient? A naught coefficient is 1, and in equation number 3 there is no a1 term, so that you have to put as 0. Then similarly u2, okay, a naught coefficient is 1, okay, then a1 coefficient is l, so you have to write like this l. Okay, this is equation number 2.9. Okay, equation number 5. Okay, equation number 5. Okay, where u1 and u2, this matrix is nothing but displacement or displacement or degree of the freedom matrix.